Statistics. Regarding the type of data, it can be categorical or numerical. Categoricals as the name depicts its categories. It can be ordinal or nominal. Ordinal means in order, like classification system. Nominal means unordered categories like gender, eye, color, or type of prosthesis. They are displaced as a bar or a pie and analyzed as a chi-square or Fisher-Exact test. Numerical, either continuous or non-continuous. Continuous means like weight, height, BP. They are described as parametric t-test. Non-continuous, also called count, as number of children. These are described by Mann-Whitney or Wilcoxon test. Then they can be paired or unpaired. Paired means from same patient person. Unpaired means from separate subject. Then they can be distribution wise normal, that is called Gaussian distribution. It has a bell-shaped curve, or skewed. Skewed can be positively skewed, where the tail is on the right hand side, and negatively skewed, where the tail comes at the beginning. Then we check the measure of tendency, that is median, mode, and mean. Mean is when average of the values, so we add all values and divide it by the number of values. Mode is a value which occurs more frequently. Median is the 50th percentile or middle value. For a perfect curve, the median, mode, and mean are all the same. For measurement of the variability, we have range. Range is lowest and the highest number. We have percentile. So we make brackets, and that is called quartile. Variable. It is the average of the corrected sum of square about the mean. Standard deviation. It is measure of the deviation of individual values from the mean. For a symmetrical bell-shaped curve, they are roughly 68% of the data, or 2 standard deviation, that is 95% of the data, or 3 standard deviation, that is 99.7% of the data. Confidence of interval at interval with specified probability of 2 standard deviation on either side. Regarding data interpretation, all good studies test an hypothesis. A null hypothesis means that if the difference has occurred is purely by chance, or there is no difference. P-value is the probability that result occurred by chance. If it is less than 0.05, null hypothesis is rejected. Smaller the p-value, stronger evidence against null hypothesis. We accept as 5%, and the p-value is 0.05%. 0.05. Type of error. Type 1 error is false positive, incorrectly rejecting a null hypothesis. This can be taken as a false alarm in a factory. If alarms and there is no problem, this is false positive. False negative, incorrectly accepting the null hypothesis. This mostly happens because of small size. This is like in a factory, if there is a fire and there is no alarm. Power. Power is the probability of finding significant association if it exists. So it estimates the probability the study will be able to detect true effect of intervention. Power is taken as 1 minus type 2 error or beta error. Power analysis is a method to determine number of subjects, sample size needed in order to have a reasonable chance of showing difference if it exists. So power is affected by number 1, size of the difference, number 2, spread of the data, number 3, acceptable level of significance, number 4, sample size, number 5, variability in observation, number 6, experimental design, and number 7, type of data. Study design. The study can be observation, where it is observation rather than altering or changing any event, like pulmonary embolism after total hip replacement surgery. It can be experimental, like a maneuver and then observe the outcome, like heparin versus placebo for the TVT prophylaxis and total hip replacement. It can be also timelined, that can be retrospective, the event has occurred and you are going back in time. They can be prospective, follow the patient or cohort forward in time, or cross-sectional studies, examine patient or event at one point in time without the follow-up. Then we comes to significant tested. It is important to think about what type of data, sample size, if distribution is normal or skewed, do data need to be transformed, is it single or two tailored p-value necessary? The test can be either for parametric data or non-parametric data. Parametric data suggests that data were sampled from normal population. The observations must be independent. Population have same variance. Can use absolute difference between the data points. Increase power for a given sample size. Non-parametric, no assumptions are made. No limitation on type of data. Rank order of values, less likely to be significant. Decrease power for a given sample size. Now talking about level of evidence. At the level, number 1 would be systemic analysis. Number 2 will be systemic review. Number 3 will be randomized controlled trials. Number 4 will be cohort studies. Number 5 will be case control. And number 6 will be case series.